Here we're asked to find the rate of change of this function d of t equals 1 over 2t. Now one of the first problems we have is that we know the rules for differentiating functions. For instance, let's just do it in terms of x, but if we have a function x to the power n, then we know differentiating produces nx minus 1. If there's a number at the front of that, then it really just stays at the front. So there it appears in there. So it's like, for instance, x squared would give you 2x to the power 1, and if it's 3x squared, it'll be 2 times 3x to the power 1. That's 6x to the power 1, 6x. So a number at the front just stays in there as you proceed with your differentiation. Now the problem here is the fact that we've got the variable t down at the bottom, and we do know that 1 over t is t to the minus 1, and that therefore allows us, if we have something like that, to use this rule of the variable raised to the power n, for instance. So that's useful. However, it's this 2 that's down there that's the awkward thing, and we should be thinking of a half, or 1 over 2t, as 1/2 times 1 over t, so that we can then isolate the 1 over t from this 2. Remember, multiplying fractions, you multiply the top two numbers, 1 times 1, the bottom two numbers, 2 times t, to give you 2t. So we really are looking at a half t to the minus 1. So let's rewrite that as a half t to the minus 1. And we're in this territory here, except the variable is t, not x. So we've got t raised to some power, but we have a number at the front which happens to be a half. So the rule would say bring down the power, that a just sits there, remove 1 from the power, take 1 away from the power. So let's do that. Differentiate this function. -1, bring the power down, times that half just sits there, times t to the power, take 1 away from -1. That would be -2, not 0. Think of your number line. If you're at -1 and you take away 1, you'll be moving to -2. This needs tidied up. The whole result will be negative. A half times t to the -2. And again, that t to the -2, think of a half times 1 over t to the +2. If there's a negative index, take that down to the bottom of the fraction, and the negative index becomes positive. So that's 1 over 2t squared. 1 times 1 is 1, 2 times t squared, 2t squared. So there's 1 over 2t squared. So that's the formula for d dashed of t. The rate of change just means differentiate. And we have to find the value of that. We have to calculate it when t equals 5. So d dashed, the rate of change of d when t is 5, just replace t by the value 5. So we get minus, or -1 over 2 times 5 squared. That's -1 over 2 times, now you do the squaring of 5 before you double. So that's 2 times 25. So d dashed of 5 is equal to -1 over 50. -1/50.